So I'll talk about the new technology we need to demonstrate to Bjarke and his friend architects, because for new cities to function the way that he depicts it, we need new technology. And the new technology that I'll be talking about is biotech, how using biotech we can create a new paradigm for a new chemical industry that is not reliant on oil. Well, I'm afraid I'll have to give you a crash course. I promise it will be short on biotechnology. I think most of you will have a different background, but here it comes. Biotechnology, industrial biotechnology uses the biotech skills that have been developed mainly for pharma to address industrial opportunities, address very often industrial problems. What we do is that we take inspiration in nature, go out, hunt for genetic diversity in nature, usually microbes. We cultivate the microbes. We do a lot of interesting things to them to train them to be better at producing exactly what we want. And then the products that come out are either enzymes. Enzymes are the catalyst that makes you and all living beings tick. You have approximately 30,000 enzymes, different enzymes in your body, and that's why you tick. Microbes also have enzymes, and we have found ways to identify enzymes that can be used in industrial applications. We can also use the microbes as such as products, and we do that very often in different applications. And of course the microbes can produce other things than enzymes and many different building blocks for this new chemical industry. Just to give you an illustration of what we do today already, enzymes is one of the big products coming out of this. We have for many years been doing life cycle assessments of our products. And here are the benefits in the many different industries where we are selling. Actually, Novozymes enabled our customers last year to save 40 million tons of CO2 by using enzymatic methods rather than the chemical methods that they used before. And to put the 40 million tons into perspective, Denmark's total emission is about 60 million tons, so 40 is something. Of course, there's more to the environment than CO2. CO2 kind of took a lot of the picture because of COP15. But in general, what we can do with biotechnology is that we can make more from less, make more from less resource input. We need less energy input. We generate less waste as we produce or as our customers produce. And then, and that'll be important for this part, we can use renewable input rather than petroleum. Now, the existing it comes out a little strange, this slide. But the existing paradigm, of course, is one where the world uses oil as input, and then the oil is consumed. 90% is consumed as energy, mainly for transportation, and 10% is used to produce all this stuff that we use in our daily life. Here is a picture, I guess it's a US family, but this is all made from chemicals. I'm sure that even if this looks like a US family, I wouldn't be surprised if a Danish family would be able to clear the house and make the garden look the same. Everything we are surrounded with, our textiles, a lot of things are produced from oil today. And as you know, we'll be running out of oil. One of the reasons that we are running out is that The transportation sector is destined to grow, and there are no good answers to fuel the transportation sector. Today we have about 800 million cars in the world. We will have additionally the 2.3 billion cars as the Chinese and the Indians start to drive in cars as well. That, of course, will suck up a lot of oil from for the transportation sector. The solution, we believe, is to use a completely different paradigm, a paradigm where the input, instead of oil, and as you know, we will sooner or later, we will be running out of oil. 40, 50 years down the road is the predictions from the International Energy Agency right now. We need something else. Something else, in our opinion, should be renewable input. And the centerpiece in this new paradigm would be what we call biorefineries. This is a biorefinery in the middle of the slide. Input for that biorefinery will be renewable input. Today, renewable input for biorefineries is sugar. Is grain in the US, sugar cane in Brazil, and the output mainly today is biofuel. That is the more or less only big volume output that we know today. In the future, and the future is actually happening as we speak, instead of using grain, we can use agricultural waste. So waste will be straw, in Denmark, wheat straw. In the United States, it'll be straw from maize, from corn. In Brazil, it'll be the residual after pressing the sugar out of the sugar cane, something called bagasse, of which there's as much as there is sugar in Brazil. And all of that will be converted into sugar. And biotech, this is done by very advanced biotech developed enzyme systems that can break down the material into sugar, and then biotech kicks in again, and we can develop a microbe that from sugar can produce building blocks for a new chemical industry. So today, and I know it's a little bit contagious subject, but today you have about 250 of these biorefineries in the US. The majority produces from corn, maize, produces sugar, and then the sugar is transformed into alcohol. In the future, they would need 600 plants in the United States that will, from waste, produce sugar and then biofuel or building blocks for a new chemical industry. The beauty of this is that there will be essentially no waste because all of the input can be used some way or other, either for the main purpose, that of producing chemical building blocks or fuel. And the waste can be used either as energy for power generation, for heat generation, or can be used as animal feed. This is how all the existing biorefineries are running now. There's almost a main production of animal feed coming out of the existing biorefineries. So the whole idea of closing the loop is part of these biorefineries. This is the World Wildlife Foundation, the World Wildlife Fund for Nature, and they issued a report like 2 years ago in which they talked about this new kind of paradigm and stressed the opportunity to close the loop. They are, in their report, are concentrating on how they can close the loop using the surplus carbon that is in the material by producing biogas. A more advanced recycling concept is one that we are developing together with a Japanese company, Mitsubishi Chemicals, where the idea is to produce building blocks from renewable resources, and these building blocks will then be part of plastic that can be degraded using enzymes. So of course, biodegradable plastic is a big thing. The problem is that we want to be able to control when this plastic should biodegrade. So we don't want the coffee cup to suddenly biodegrade in front of us. Somehow you need to be able to control that. And that's what we are developing together with Mitsubishi Chemicals, is from renewable input, make your building blocks, make a polymer that you can easily break down enzymatically to its monomers, so you can make the plastic after that process. Mitsubishi are planning to run a pilot experiment in a small city somewhere in Japan, where they will kind of establish collection systems and then break down the plastic this way and recycle it, use it again for new plastic. There are many kind of proponents of this, so it's not only Novozymes that is pushing this new concept. OECD have made several reports. This is the newest. As I mentioned, the WWF have made a report on the subject. And this year, the World Economic Forum came out with a report on the subject. All of them kind of realizes that there's a big potential. And now, since today's subject is growth, there's a lot of opportunities for growth in this, growth that will not rely on exhaustible resources, growth where we can use renewable input, and growth where we will use much less raw material input, less energy, and virtually create no waste. The way it's going to be implemented is, of course, first we have to get up the learning curve. In the US, they have used the biofuel, the corn-based biofuel that we hate in Europe, to get up the learning curve. The system in the United States is now such that 10% of US gasoline is biofuel produced this way from their excess maize, excess because they went from normal crops to GMO crops, and that gave them a huge jump in productivity. 10% of global gasoline actually equates to 5%, 10%, sorry, of US gasoline is equivalent to 5% of global gasoline, as the US consumes half the world's gasoline. So 5% of the world is coming from the United States this way. And after 10 years in which this business was subsidized, the subsidies are being phased out by the end of this year. It's now a business that is competing well with oil. So they don't need subsidies. And on the contrary, actually, it was calculated that last year, this type of gasoline with 10% blend ratio saved every American family $800 US. Well, this apparently moves on without permission. The first generation is only going to fly in the United States because of the special circumstances there. But the next phase, that of second generation, is about to happen. Now the first factories will be built. They'll start building this year in the United States. The first European factory is being built in Italy. The first Chinese factories will be built, the construction will start by the end of this year. In China, they expect that in the next 5 years they'll build 10, and then they'll build 100 in the 5-year period after that. And the opportunity then is to use the big market of energy to bring down the cost of producing the sugars so that the sugars can be used for all the other construction chemicals or all the other building blocks that we need in the future. These are some of the other companies that are working with that. As you can see, Genicor is on the map. Genicor that was from Danisco that was recently sold to DuPont. So there's actually a lot of Danish interest and a lot of Danish expertise in this. We work, for example, with Braskem to produce renewable plastic, the type of plastic that you for your water bottles is polypropylene, and we are trying to develop a method where they can use bagasse, the waste from sugarcane, to sugar to polypropylene. We have another application where we develop from sugar, again the same, the building block for superabsorbers that is used in baby nappies. Again, there's a lot of things happening around the globe. People are building as we speak, pilot facilities. One thing I wanted to tell you about from this one is that you can see there's a Chinese company, Daqing, on that slide. Daqing is a huge Chinese company. It's operating on a global scale, mainly producing though in China. They use as raw material input corn starch. They are headquartered in Jilin province. Jilin is the province in China producing the most corn, 20 million tons. The problem though is that Daqing already now, last year, consumes 4 out of the 20 million tons. And this is you can say, the corn basket of China. And of course they realize, as does now many Chinese companies, that they are running out of resources. They are resource constrained in China in a way that we don't really comprehend before we are there here in Europe. So these guys in Daqing are very, very eager to use the corn stovers, the corn straw, instead of using the corn, not because they don't want to use the corn, but simply because they realize that they will not be allowed to use more than the 4 million out of the 20 million that they're already using. So I had a meeting with them last year. They are now building a pilot facility. When I go see them in week 42, they promised me that the pilot facility is up and running. They would then, end of this year, build a real scale facility. And the plan is to use most of the straw in Jilin to continue to feed Daqing as they grow. We have now about 15 other leads in China, companies, big companies in China that are resource constrained. So there's no doubt that they have seen it before in China. They have seen this resource constraints much faster than anybody else. This is just to tell you where the different players are. I think I already mentioned most of that. Europe, apart from the fact that we have an Italian partner that is building the first European big-scale facility, not so much is happening. Denmark, we have the biggest demonstration facility, though, in Kalundborg, Empicon, owned by Dong. But despite a lot of efforts from our side and that of Dong and many other players, it has not really been possible to convince Danish politicians that we should embark on this road here. despite the fact that we will, as of next year, be a net importer of oil in Denmark, then despite the fact that if we build these facilities in Denmark, second generation, we would build them in rural Denmark, udkants Denmark, where we need jobs, and that these are jobs that you cannot export to China. So I think there are many good things to be said for this, things that I've said so many times, but with little impact so far in Denmark. As this industry grows, we are, of course, competing with a technology, a petrochemical-based technology that is more than 100 years old. 150 years they have had to practice in the chemical industry, which, of course, have given them a big advantage as we now start to compete with our new technology, where we have to somehow compete against an existing infrastructure, compete against factories that have been basically written off, compete against factories where they have been optimizing for 150 years. So in the beginning, it's a little bit tough. Of course, the good thing is that their technology is old and tired, whereas our technology is virginal and basically still underexplored. There's so many things we can still do with this that I'm sure that give us another 10 years and we'll be able to meet the cost targets for most of the products. Already now, there's a number of products that where the input as sugar is cheaper than input from oil. Yeah, so when I meet my own scientists, of which we have 1,200, then of course they like this challenge, and they are ready to go, as are many other companies. And as architects develop new cities, they need this kind of technology to make the cities function. Thank you.